Section 14.4, more applications of quadratic equations. The objectives: use quadratic equations to solve applications involving A, the Pythagorean theorem, B, work, C, distance, rate, time, D, projectiles, E, geometry, and F, cost per person. Example 1. The length of a rectangle is 7 feet longer than the width. If one diagonal measures 13 feet, what are the dimensions of the rectangle? For our solution, we're going to draw a diagram for the problem involving geometric figures whenever possible. In this case, we're going to draw a rectangle where we have the diagonal is 13. We know that the 90 degrees sits opposite of the diagonal. One of the sides is x, the other side is x plus 7. So we let x be the width of the rectangle, and x plus 7 be the length of the rectangle. Then using the Pythagorean theorem, we're going to have the quantity x plus 7 squared plus x squared equals 13 squared, which is x squared plus 14x plus 49 plus x squared equals 169. Collecting like terms and moving 169 to the other side by subtracting it, we have 2x squared plus 14x plus 49 minus 169 equals 0. Collect like terms with our constants, and we have 2x squared plus 14x minus 120 equals 0. We're going to take out our greatest common factor of 2, which leaves us with x squared plus 7x minus 60 equals 0. Try to factor that, and that factors into x minus 5 times x plus 12. So our factored form is 2 times x minus 5 times x plus 12 equals 0. We'll set each factor that's linear equal to 0 and solve. X minus 5 equals 0. We're going to add 5 to both sides, which gives us x equals 5. X plus 12 equals 0. We're going to subtract 12 from both sides, giving us x equals negative 12. We throw that solution out because negative numbers are not going to fit the conditions of the problem. We can't have a negative length. So our answer is x equals 5 and x plus 7 equals 12. We can check that by checking that 5 squared plus 12 squared really does equal 13 squared. 25 plus 144, does that really equal 169? And it does. 169 equals 169. So the width is 5 feet and the length is 12 feet. Example 2, working for a janitorial service, a woman and her daughter can clean a building in 5 hours. If the daughter were to do the job by herself, she would take 24 hours longer than her mother would take. How long would it take her mother to clean the building without the daughter's help? Here we're going to set up a table. So we're going to have hours to complete, part completed in 1 hour for our column headings. We're going to have mother, daughter together. We're going to let x equal the time for the mother to do the job alone, and x plus 24 equal the time for the daughter to do the job alone. So hours to complete the job for mother is x. The part completed in 1 hour is 1 over x. X plus 24 is the hours it takes the daughter to complete the job. The part completed in 1 hour for the daughter is 1 over x plus 24. And then we know that together they can complete the job in 5 hours. So the part completed in 1 hour for them together is 1/5. So the part done by the mother in an hour plus the part done by the daughter in an hour is going to equal the part done working together in an hour. So we're going to have 1 over x plus 1 over x plus 24 equals 1 over 5. We're going to multiply everything by the least common multiple of the denominators, which will be 5x times x plus 24. So you see that there. We're going to each term times 5x times x plus 24. When we get done simplifying, that's 5 times x plus 24 plus 5x equals x times x plus 24. We distribute on both sides. We have 5x plus 120 plus 5x. Distributed on the right, we have that equal to x squared plus 24x. Now we're going to move everything to the right by subtracting both 5x's and the 120. That leaves us with 0 equals x squared plus 24x minus 10x minus 120, which is 0 equals x squared plus 14x minus 120. That factors into x minus 6 times x plus 20. If x minus 6 equals 0 or x plus 20 equals 0, for the first one, we'll add 6 to both sides, so x equals 6. For the second one, we'll subtract 20 from both sides, so x will equal negative 20. We throw that solution out because we're talking about time. You can't have negative time. So the mother could do the job alone in 6 hours. Example 3, a small plane travels at a speed of 200 miles per hour in still air. Flying with a tailwind, the plane is clocked over a distance of 960 miles. Flying against a headwind, it takes 2 hours more time to complete the return trip. What was the wind velocity? The basic formula is distance equals rate times time, or D equals RT. We also know that time is equal to distance over R, or T is equal to D over R, and that rate is equal to distance over time, or R is equal to D over T. So we're going to let x equals the wind velocity. Then 200 plus x will be the speed of the airplane going with the wind, which is a tailwind. 200 minus x will be the speed of the airplane returning against the wind, which is a headwind. And distance is 960 each way. We know the distance and can represent the rate or speed. So the formula is T equals D over R. Again, we'll kind of use a table to set this up. We have distance, rate, and time for our columns, going and returning for our rows. The distance going is 960. The rate going is 200 plus x. Time is 960 over 200 plus x, or distance over rate. For the trip returning, again, 960 miles. The rate is 200 minus x. The time it took is 960 over 200 minus x. So we know the time returning minus the time going is equal to the difference in time. So 960 over 200 minus x minus 960 over 200 plus x is equal to 2. Remember, that's the difference in the time. So once again, we're multiplying by our lowest common denominator, which would be 200 minus x times 200 plus x. When you simplify that down, you have 960 times 200 plus x minus 960 times 200 minus x equals 2 times 40,000 minus x squared. That's what you get when you multiply it out, the 200 minus x and the 200 plus x. Distributing, we have 192,000 plus 960x minus 192,000 plus 960x equals 80,000 minus 2x squared. So we have 2x squared plus 1,920x minus 80,000 equals 0. So that was collecting the like terms. So the 192,000s divide out. 960x plus 960x is 1,920x. We added the 2x squared and subtracted the 80,000. So now we'll divide everything by 2. That gives us x squared plus 960x equals 40,000. And here we're taking everything and dividing by 2. So the 2x squared, the 1,920x, the negative 80,000, and also this 0. So what you do to the left, you have to do to the right. That factors into x minus 40 times x plus 1,000 equals 0. Setting each factor equal to 0, I have x minus 40 equals 0, and I have x plus 1,000 equals 0. When I add 40 to both sides, I get x equals 40. When I subtract 1,000 from both sides, I get x equals negative 1,000. Once again, we throw that solution out because you can't have a negative velocity. So the wind velocity was 40 miles per hour. We can check that by putting the 40 into our equation. 960 over 200 minus 40 minus 960 over 200 plus 40. Does that equal 2? That gives us 960 over 160 minus 960 over 240. Does that equal 2? That's 6 minus 4. Does that equal 2? And yes, it does. Example 4, a bullet is fired straight up from ground level with a muzzle velocity of 320 feet per second. A, when will the bullet hit the ground? In this problem, the initial velocity, v sub 0, is 320 feet per second, and the initial height, which is h sub 0, is equal to 0 feet. So the bullet hits the ground when its height, h, equals 0. So h equals negative 16t squared plus v sub 0t plus h sub 0. That's our formula. The height when the bullet hits the ground was 0, so we have 0 equals negative 16t squared plus 320t plus 0. Simplifying, that gives us 0 equals t squared minus 20t. They just divided everything by negative 16. Factoring out the greatest common factor, we have 0 equals t times t minus 20. So t is equal to 0 or t is equal to 20. The bullet hits the ground in 20 seconds. The solution, t equals 0, confirms the fact that the bullet was fired from the ground. For B, when will the bullet be 1,200 feet above the ground? In this part of the solution, we're going to let h equal 1,200. So this time the formula is 1,200 equals negative 16t squared plus 320t. Subtracting 1,200 from both sides, we have 0 equals negative 16t squared plus 320t minus 1,200. We're going to divide everything by a negative 16, which gives us 0 equals t squared minus 20t plus 75. And that factors into t minus 5 times t minus 15. So t could be equal to 5 or t could be equal to 15. Both solutions are meaningful. The bullet is at a height of 1,200 feet twice, once at 5 seconds while going up, and once at 15 seconds while coming down. Example 5. A square piece of cardboard has a small square, 2 inches by 2 inches, cut from each corner. The edges are then folded up to form a box with a volume of 512 inches cubed. What are the dimensions of the box? Your hint is the volume is the product of the length, width, and height. V equals LWH. For this solution, we're going to draw a diagram that illustrates the information. So here's a picture of a square with 2-inch squares cut out of each corner. We know that one side would be X, and that other little piece, X is going to be the length of one side of the square piece of cardboard, the whole length. And then the length X minus 4, once we cut those pieces out, times the width, which would be X minus 4, is going to be multiplied by the height, which is going to be 2 when you fold it up. So here's a visual of it in 3 dimensions. So the 2 sides are X plus 4, length and width, whichever way you want to call it, and then the height is 2. So the length is X minus 4 times the width is X minus 4 times the height is 2, and that's all equal to 512. which is x minus 4 times x minus 4 equals 256. So there we divided both sides by 2. And then x squared minus 8x plus 16, after I multiply that out, is equal to 256. Now I subtract 256 from both sides, and I end up with x squared minus 8x minus 240 equals 0. That factors into x minus 20 times x plus 12 equals 0. So my two factors are x minus 20 equals 0 or x plus 12 equals 0. On the first one, we're going to add 20 to both sides, so x equals 20. On the second one, and then x minus 4, the other dimension is 16. And then on the other one, we're going to subtract 12 from both sides, which we throw that solution out because you cannot have a negative distance. So the dimensions of the box are 16 inches by 16 inches by 2 inches. Example 6. A Little League baseball field is in the shape of a square with sides of 60 feet. What is the distance to the nearest tenth of a foot the catcher must throw from home plate to second base? So here you see the dimensions. We're going from home plate to second base. There you see we have 60, which if it's a square, all the sides are 60. So the distance from home plate to second base is the hypotenuse of a right triangle with sides of length 60 feet. We use the Pythagorean theorem and we get x squared equals 60 squared plus 60 squared. So x squared equals 3,600 plus 3,600. X squared equals 7,200. X is equal to the square root of 7,200. In this case, we don't do plus or minus because we know we're talking about distance, so we just worry about the positive value. And so x equals 84.9 feet when we round to the nearest tenth of a foot. The catcher must throw about 84.9 feet. Example 7. The members of a bowling club were going to rent a bus to drive them to a tournament at a total cost of $2,420. Which was to be divided equally among the members. At the last minute, 2 of the members decided to drive their own cars. The cost to the remaining members increased $11 each. How many members rode the bus? For our solution, we're going to let x equal the number of club members and x minus 2 equal the number of club members who rode the bus. The final cost per member is going to be $2,420 divided by x minus 2, minus the initial cost per member, which would have been $2,420 over x, and that's going to equal the difference in cost per member, which was 11. So once again, we'll multiply everything by our lowest common denominator of x times x minus 2. So you can see what divides out. So on the left, we have 2,420x minus 2,420 times x minus 2, equaling, on the right, 11x times x minus 2. Multiplying everything out, that's 2,420x minus 2,420x plus 4,840 equals 11x squared minus 22x. Collecting like terms and setting everything equal to 0, the 2,420x minus 2,420x, those are going to add to 0. So really you had to just subtract the 4,840. So we have 0 equals 11x squared minus 22x minus 4,840, which if we divide everything by 11, we get 0 equals x squared minus 2x minus 440, which factors into x minus 22 times x plus 20. And solving the first one, we get x equals 22. Solving the second one, we get x equals negative 20. Once again, we throw out the negative solution because you can't have a negative cost per person. So then if x is 22, then x minus 2 is 20, which is, I think, what we want to know, how many people actually rode the bus. So to check our solution, the final cost per member is equal to $2,420 over 20, which is $121. The initial cost per member would have been $2,420 over 22, which would have been $110. And then $121 minus $110 is $11. That's the difference in cost per member, which was what we wanted. And so that meant that 20 members rode the bus.